Basic anatomy, immune lymphatic system. Main function, protects the body from infection and disease. 1. Main components, spleen, lymph nodes, and bone marrow. 2. Clinical application, blood test to count white blood cells. Lymph node biopsy to detect cancer. Detailed explanation of the immune system. The immune system is the body's defense system that functions to protect the body from various pathogens, such as bacteria, viruses, fungi, and parasites, as well as from damaged or cancerous cells. The immune system also plays a role in identifying and destroying foreign microorganisms that can cause disease and maintaining balance in the body. The immune system works through various highly organized mechanisms and consists of several components that interact with each other to fight infection and keep the body healthy. 1. Main function of the immune system, protects the body from infections caused by pathogens, such as viruses, bacteria, fungi, and parasites. Destroys infected or cancerous body cells, thereby preventing the spread of disease. Detects and eliminates abnormal or damaged cells. Builds immunity, so the body is better prepared to fight future infections through a faster immune response. 2. Main components of the immune system. 1. Lymphatic organs and tissues. These organs are involved in the production, maturation, and activity of immune cells. Bone marrow, site of production of most blood cells, including immune cells such as lymphocytes, consisting of T, B, and natural killer cells. Thymus, site of maturation of T lymphocytes, which are important for cellular immune responses. Lymph nodes, spleen, a meeting place between lymphocytes and pathogens. Lymph nodes also filter lymph from microbes or abnormal cells. Neuromusculature, structures that function as the body's first line of defense against pathogens, including the skin and mucous membranes. 2. Immune cells, lymphocytes, the main cells in the immune system that play a role in recognizing and attacking pathogens. T lymphocytes, involved in cellular immune responses and kill infected or abnormal cells. T lymphocytes are divided into T helper, which help stimulate B lymphocytes and other T cells, and T cytotoxic, which directly kill infected cells. B lymphocytes produce antibodies, immunoglobulins, that function to neutralize pathogens and mark them for destruction by other immune cells. NK, natural killer cells. Natural killer cells that can recognize and destroy cells infected with viruses or tumor cells. Macrophages, large cells that phagocytose, eat pathogens, dead cells, and dust. They also serve to stimulate other immune cells to work. Neutrophils, white blood cells that first respond to bacterial infections by destroying pathogens. Dendritic cells, cells that function to capture and process antigens, foreign substances, and then introduce the antigens to lymphocytes, especially T lymphocytes. 3. Antibodies, immunoglobulins, function. Proteins produced by B lymphocytes to recognize and bind antigens, foreign substances, such as bacteria and viruses. Antibodies mark pathogens for destruction by other immune cells. Types of antibodies. IgG, the most common type of antibody and fights bacteria and viruses. IgM, antibodies that are first produced when a new infection occurs. IgA, found on mucosal surfaces, such as the digestive tract and respiratory tract, helps fight local infections. IgE, involved in allergic reactions and responses to parasites. IgD, involved in antigen recognition and initiating the immune response. 4. Complement system. Function. A system of proteins in the blood that helps antibodies and other immune cells fight pathogens. These proteins work together to kill infected bacteria or cells and promote inflammation to speed up the immune response. Cascading effect. When the complement system is activated, a series of chemical reactions occur that can damage the membranes of pathogens or attract more immune cells to the site of infection. 3. Immune response process. 1. Innate immune response. This is the body's first response to an invading pathogen and is non-specific, meaning the body recognizes the pathogen based on common patterns, e.g., bacterial surfaces. Components. Skin and mucous membranes, the first physical barrier to pathogens. Macrophages and neutrophils, cells that quickly react to pathogens by phagocytizing and destroying them. Complement proteins, help destroy pathogens directly. Inflammation. The inflammatory response occurs when the body recognizes an infection. Blood vessels dilate and increase blood flow to the infected area, bringing more immune cells to fight the pathogen. 2. Adaptive immune response. A more specific immune response that remembers pathogens that have previously entered the body. When the same pathogen re-enters the body, the immune system will respond more quickly and more strongly. The process, antigen recognition. Dendritic cells process antigens and present them to T lymphocytes. T and B lymphocyte activation. T lymphocytes help kill infected cells, while B lymphocytes produce antibodies to fight the pathogen. Immune memory. After infection, some T and B lymphocytes become memory cells that remain in the body to respond more quickly if the same pathogen attacks again. 3. Recovery phase. After the pathogen is destroyed, the body enters a recovery phase where immune cells that are no longer needed die, and the body returns to normal. 4. Immunity. 1. Natural immunity. Innate. Protection that is present from birth, such as skin, mucous membranes, and innate immune cells. Acquired immunity that develops after the body is exposed to an infection or vaccination. The immune system remembers the pathogen and provides better protection if exposed in the future. 2. Vaccination. Function. Vaccines contain antigens from weakened or killed pathogens. So the immune system can produce antibodies and memory cells without causing disease. Benefits. Sharpens the body's immune response to pathogens without causing serious disease. 5. Immune system disorders. 1. Immunodeficiency. Definition: disorders in which the immune system does not function properly, making the body more susceptible to infection. Example: HIV/AIDS, where the virus destroys T lymphocytes, especially CD4+ cells, making the body unable to fight infections. 2. Allergy. Definition: an exaggerated immune response to a substance that is actually harmless, an allergen. Example: asthma, allergic rhinitis, or allergic reactions to food or drugs. 3. Autoimmunity. Definition: when the immune system mistakes the body's own cells for pathogens and attacks them. Examples: lupus, rheumatoid arthritis, or multiple sclerosis. 4. Cancer. Definition: the body's cells grow uncontrollably, sometimes avoiding detection by the immune system. Examples: lymphoma and leukemia, which involve immune cells turning cancerous.